Hello everyone and welcome to today's session. Today we will be doing Mathematics 1, and in Mathematics 1 we are going to take chapter number 4, Ratio and Proportion. Now in this chapter, what are the contents which we are going to cover? Ratio, the properties of ratio, the operations on equal ratios, theorem of equal ratios, continued proportion, K method. Before we start with the ratio and proportion chapter, let's recall certain things which we have done in our previous standards. In earlier standards, we learnt about the ratio and proportion. We have also solved certain examples related with that. Let us see one of the example where we can solve a certain thing. The Rava Laddu prepared by Vimal, or tasty, for which she takes 1 bowl of ghee, 3 bowls of rava and 2 bowls of sugar. Here if you see, the proportion of rava and sugar is 3:2. The contents which are given to us is ghee, rava and sugar. Here we are taking the proportion of rava and sugar in 3:2 or 3/2. If the same thing, if 12 units of rava is to be used, then how many units of sugar are required? To find this, let us suppose that the number of bowls of sugar required be X. Now we are taking the number of bowls of sugar to be X. We suppose it. Now, from this information, what we get, that the proportion of rava and sugar is 3:2, and we need to find 12 units of rava. If 12 units of rava used, then how many sugar are required? So we assume a variable for that. We have 3x is equal to 24 when we cross multiply this. Therefore, what will be the value of x? Here if you see, x is getting multiplied, and when this 3 comes on the other side, we get x is equal to 24 upon 3. That gives me x is equal to 8. That is, for the preparation of laddu with 12 units of rava, we require 8 units of sugar. Now, alternatively, you can solve the same example by assuming a variable k, a constant k. Let us say 3k bowls of rava. It requires 2k bowls of sugar is required. Then we have 3k upon 2k is equal to 3/2. If 3k, this 3k is equal to 12 units, 12, then what will be the value of k? K will be 4, because here you see 3 is multiplied with k, and when this 3 comes here, it becomes division. So we get k is equal to 4. So we got the value of k. Now we can substitute the value of k here. 2k is equal to 2 into 4, which is equal to 8 bowls of sugar. That means we require 8 bowls of sugar. Let us see a concept called as direct variation. What happens in direct variation? We will see an example. Based on an example, we will see how direct variation works. A car covers a distance of 20 kilometers. Now this car is covering a distance of 10 kilometers, consuming 1 liter of petrol. It will cover a distance. Now here we have petrol in liters, and here we have the distance in kilometers given to us. Now, if you see over here, 1 liter, it takes 10 kilometers. Then if you use 20 liters of petrol, then how much distance it is covering? We have 20 into 10, which gives me 200. So this 200 has come here, right? Consuming 40 liters of petrol, if the same car consumes 40 liters of petrol, then how much distance will it cover? So 40 into 10 gives me 400. Now if you see here, the ratio of the consumption of petrol and the distance covered by the car. The consumption of petrol is in liters and the distance covered by the car is in kilometers. If you see here, you have 1 upon 10. Here you have got 1 upon 10. From this, what do we find? We find that these two quantities have got the ratio as constant. So we say that in such a case, it is said that the two quantities are in direct proportion or in direct variation. What happens over here? When one quantity increases, you will find that the other quantity also here increases. This increased, this also increases. If one quantity decreases, then the other quantity also decreases. Such a case where two quantities are said to be in direct proportion or in direct variation. Now, inverse variation. Let us take an example with inverse variation. A car takes 2 hours to cover a distance of 100 kilometers. Now the car is taking 2 hours to cover a distance of 100 kilometers. And what is the speed of the car? If you see, it is 50 kilometers per hour. Similarly, if you see a bullock cart, there is a comparison between these two. Takes 5 kilometers in 1 hour. It travels 5 kilometers in 1 hour. Now, to cover a distance of 100 kilometers at the speed of 5 kilometers per hour, the bullock cart takes 20 hours. Right? Now, the car, you see the speed of the car is 50. Time 2. It gives me, because we know that speed into time is equal to distance. Here the product of the speed of the vehicle and the time, it remains constant. Let us take the bullock cart, speed 5 and the time 20. Again, if you see, we get the product of speed into time as constant. Here we get 100, here also we get 100. Now, in such quantities where you get the product of the speed of the vehicle and the time constant, it is said to have inverse proportion or it is an inverse variation. Here, when one quantity increases, the other quantity decreases. So, such quantities are said to be in inverse proportion or in inverse variation. Let's move to some of the properties of ratio. Let us take two numbers, ratio of numbers A and B. Now, how it is written? We have seen in our previous standard how it is written. It is written as A is to B or A upon B. What does this A call here? This A is called as the predecessor, which is the first term, and B is called as the successor, which means the second term, the term after the first term. So A is the first term and B is the second term. In the ratio of two numbers, say, suppose this, the second number, the second term we say it is 100. Then what it is? No. What it is called? It is called as the percentage, because this percentage we always expressed it in 100. Percentage is always expressed in 100. So when the second term, that is this B, which is the successor, it is 100, then it is known as percentage. The ratio remains unchanged if the terms are multiplied or the terms are divided. Anyway, if it is multiplied it by any non-zero number, this non-zero number, it should not be zero. That is why it is said if it is multiplied or either it is divided by a non-zero number, this ratio remains unchanged. Now, for example, 3:4 is 6:8, which is equal to 9:12. Similarly, for three proportions, 2:3:5 is 8:12:20. If k is a non-zero number, then A is to B is AK, which is to BK, and A is to B is to C is AK, is to BK is to CK. The quantities taken in the ratio, which is very important, this we have to keep in mind, that the quantities taken in the ratio must be expressed in the same unit. As we will be doing certain problems, they will explain you how we are going to express it in the same unit. Finally, when we see the ratio of two quantities is unitless. Once we find the ratio, the quantity, the output, the result, what we are getting, it is a unitless quantity. For example, let us consider one example, a ratio of 2 kg and 300 grams. Look at the ratio very correctly. Here, what is the quantity given to us? Kg, that is in kilograms. Here, what is the quantity given to us? Grams. And what does property number 4 tells us? That the quantities which are taken into ratio must be expressed in the same unit. Are they in the same unit? This kilogram and this gram, are they in the same unit? No, they are not in the same unit. If we write like this, 2:300, and then, is it correct? No, because they are not expressed in the same quantity. So to convert it, we will take kilogram and we will convert it into grams. So 2 kilograms gives me how much grams? It will give me 2000 grams. So now I can express my ratio as 2000:300. And how this will come to me, if you see here, I have got 2000 upon, I have got the ratio as 300, right? This zero gets cancelled. This zero gets cancelled. What do I have? I have 20 upon 3. Now this 20 upon 3 is expressed in the same quantity, which gives me the ratio as 20:3. So very important is here is the property number 4, which tells us that the quantities taken in the ratio must be expressed in the same unit. As we move on to the next slide, let us see our practice set 4.1. Let us start with the practice set 4.1. What does practice set 4.1 tell me, from the following pairs of numbers, there are numbers given to me, a pair of number. We have to find the reduced form. We have to find the reduced form of the ratio. And how? This is also important. The first number and the second number. We have to find the ratio of the first number to the second number. Okay, let us solve the first sum. Solution. Okay, ratio of, we want the ratio, so we will write the ratio of 72 to 60. And what is the ratio of 72 to 60 when we are expressing this is equal to 72 upon 60. Now here we have to be little careful and we have to find the factors of 72. Take one table where you multiplied a number. You multiply a number, you will get 72 and you will get 60. So if I try to multiply in my mind, 12 fives are here, I know it is 60. So does any number in 12 gives me 72? Let us see, 12 fives are 60, 12 sixes gives me 72. So what I write is 12 into 6 upon 12 into 5, which is equal to. Now here if you see 12 ones are 12 ones are. What we got is 6 upon 5. And what will be the ratio of this 6 upon 5? And when we are writing this, how we are going to express this, which is equal to, we have to express it in ratio. 6, you can see this two dots which is called as 6 is to 5. Let us move with the second sum which is given to us is 38 and 57. There are two ratios given to us is 38 and 57. So let's solve this. We write with solution. Ratio of, first we will write the ratio of 38 to 57, which is equal to. Now when we got the ratio of 38 to 57, we have to write the ratio of 38 to 57. We write 38 upon 57. Now 38 is in the numerator, 57 is in the denominator. Now if you want to find the factors, we have to choose a number in the table such that the number goes in the numerator as well as the denominator. So when I want to write any table, so let us choose one table here. Which table we feel it will go? Now this is equal to, suppose I take 19 times table, 19 ones are 19, 19 twos are gives me 38 and 19 threes are gives me 57. 19 twos are 38 and 19 threes are 57. So when I'm writing this, I've chosen a table which gives me 19 into 2 and 19 into 3. Now 19 ones are gives me 19, 19 ones are gives me 19, which is equal to 2 upon 3. Now how will I express this ratio? I have to express this though this is equal to 2 is to 3. So these were the two terms where we, first two sums where we did the reduced form of the ratio of the first number to the second number. Let us move on with the third one, which is given to us as 5278. There are two quantities given to us. The first is 52, the second is 78. So let's start this. Solution. Ratio of, that word we have to write here, ratio of 52 upon 78. Now let us find one table where we have 52, also we have 78. We need to have a table. Let us think a table, or we can remove factors from that. But we know that 26 into 2 gives me 52, and 26 into 3 gives me 78. So let us write this table, which is equal to 26 into 2 and 26 into 3. Now 26 ones are 26, 26 ones are 26. What do we get? We get 2 upon 3. So what will be the ratio here? Here we will get 2 is to 3. I hope these three sums which we have done will be very clear to you all. As we move on to the next one, find the reduced form of the ratio of the first quantity to the second quantity. Look, what does the sum say? Reduced form. We are doing reduced form, but the ratio of the first quantity to the second quantity. Here we have to keep in mind that when two quantities are given to us, are the two quantities same? Are the two quantities same given to us? If yes, it is given to us as same, then we can solve it. If it is not same, then we will bring it to the same quantity. So let's start with the first one. Solution. Okay, here, what is the first quantity given to me? 700. What is the next quantity, second quantity given to me? 308. So I wrote it in a proper form, right? Now to get this, we have to think about a table where we can get the factors of this. I feel if you look at this, this is 700 given to me. Look at this. Can I say 7 into 100 gives me 700? Yes. 7 into 100 gives me 700. Now, what about this 308? What about 308? We have 7 into 7 multiplied by which number will give me 308. We can multiply here also, we can see. Suppose we take 44 here, multiply it with 7 and see. 7 fours are 28. 7 fours are 28 and 2, 30. It gives me 308. So can I say that 7 into 44 gives me 308. Now here 7 into 100 gave me 700. 7 into 44 gave me 308. 7 7 ones are 7, 7 ones are 7. What I have with me is 100 upon 44. I have got 100 upon 44 with me. Now let me see further, can I reduce this 100 upon 44? Can I reduce this 100 upon 44 further? Yes, I can reduce this 100 upon 44 further. Now looking at 100, we can immediately say that 25 into 4 is 100 here. We can say 20. But does 25 goes in this 44? It will not go. 25 ones are 25. 25 twos are 50. But we have 44 over here. But can we use 4 for 44? 4 11s are 44. So we can use this as 4 into 25 upon 4 11s are 44. So I got 4 into 25 upon 4 into 11. 4 ones are 4, 4 ones are 4, which is equal to 25 upon 11. Can I further reduce this quantity? Look at this quantity. Can we further reduce this quantity? It is 25 here, it is 11 here. That means we have finished reducing. It cannot be further reduced. Now this has to be expressed it in the ratio form, which is equal to 25 is to 11. Let's take one more sum. 14 rupees, 12 rupees 40 paise. If you look at this, properly, you have got here 14 rupees. Here you have got paise. Very carefully see here. You have got paise, you have got rupees. As the fourth property told us, what did the fourth property tell us? That the units have to be same when we are the quantities should be same. But if you look here, you have rupees. Here also we have rupees, 12 rupees. But with 12 rupees, what we have is 40 paise. Now, we have to convert this rupees into paise. How we'll convert this? Let's do it and see. Solution. What does 1 rupee consist of if you say? Rupees 1 has got how many paise? 10, 20, 30, 40. How much rupees 1 has got? 100 paise. Rupees 1 has got 100 paise. So based on this, we are going to see how many paise 14 rupees has got. So let us see. 14 rupees is equal to. Now we had 14 with us. 14 multiplied by, and we have to convert this into paise. So 14 multiplied by 100 gives me. How much 14 multiplied by 100 gives me? It gives me 1400 paise. Very carefully we have to write here 1400 paise. What is the next quantity if you see? It is 12 rupees 40 paise. 12 rupees 40 paise. Now this is equal to, paise we'll keep as it is 40 paise, but we'll convert this first half of this. And what is the first half? It is nothing but it is 12 rupees. So to convert this 12 rupees, we'll convert this into paise. 12 into 100, and to this 100, what I have got? I have got 40 paise. So I will add 40 paise to this. Now this is equal to 12 into 100 gives me how much? 1200 plus 40. Now 1200 plus 40 gives me how much? 1240 paise. Now here we have to find the ratio. They told us to find the ratio of the first quantity to the second quantity. So to find the ratio of the first quantity to the second quantity, let us write ratio of $1400 paise to 1240 paise. This is equal to. Let us write the ratio for this. So when we are writing the ratio for this, we are going to write 1400 upon 1240. Now we have got 1400 upon 1240. We have to reduce it to the lowest term. Now if you look at this properly, you will see 1 0 from here and 1 0 from here goes. So we can reduce it to the lowest quantity. What we got? We got 140 upon 124. See how much is reduced. Can we further reduce it? Can we further reduce it? Can we find certain factors to reduce it? Let us see. Suppose you use one table where we are going to use them. So suppose I use 4 times table, because in the units place you see you have got 0, 0, 2, 4, 6, 8. It can go by 4. Here also in the units place you have got 4. So if I use 4 into 35, let me see, 4 into 35 gives me 35 into 4. 5 4s are gives me 20. 4 3s are 12. 13, 14. It gives me 140. So 35 into 4 can give me 140. So what I will get with 4? Can I use 33? Let me see. 33 into 4. 4 3s are 12. 4 3s are 12 and 1, 14. I am getting 142 with 33. I am getting 4 3s are 12 and 1, 13. 132. So I want lesser. I've got 124. Can I use 31 and see here? 31 into 4. Because I have to reduce it. 4 1s are 4. 4 3s are 12. I got 124. That means if I take 4 times table here, 4 into 35, it gives me 140. And what is 124? Same, 4 into 31. 4 1s are 4, 4 1s are 4. And what I get from here? I get 35 upon 31. Check whether we can reduce it further. If we can reduce it further, we will reduce it. But this is 5 7s are 35, 5 6 are 30, or 7 times table, it will not go. So we get the reduced quantity as 35 is to 31. 1. Here you have to be very careful when you are converting it into a smaller quantity, because here if you see, we have taken this rupees and we have converted it into paise, which is very important while we are converting this. Let's take one more sum, liters and milliliters. Here again, see here what is the quantity we are getting here is milliliters, and what we are getting here, liters. As I told you, as property number 4 said, that both have to be in the same unit, in the same quantity which we are going to do. So let's solve this solution. What we have, can we convert this milliliters to liters, or can we convert liters to milliliters? Yes, let us convert the liters to milliliters, which will be very easy for us. So to convert this, let us write 1 liter is equal to, what does 1 liter consist of? How many milliliters it will have? It will have 1000 milliliters. 1 liter will have 1000 milliliters. So now let us convert this 5 liters. Let us convert this 5 liters. What will be happen to this 5 liters? Let us convert this 5 into 1000. Now 5 into 1000 will give me how much? 5000 milliliters. If you keep in mind 5000, can we do anything to this? No, we don't have to do anything to this because it is already in milliliters. So there's no need to convert this. So now we will write the ratio of ratio of 1000 or 5000 milliliters to 2500 milliliters. We have to find this ratio. Okay, to find this ratio, $5,000 upon 2500. Now, if you look at this quantity, you have 5000 upon 2500. Now, to convert this, let us solve this fraction. Can we solve this fraction? Can we reduce it with its zeros? Yeah, we can reduce it. This zero, gone. This zero, gone. And how much we get? We get 50 upon 25. We have got 50 upon 25. Can we further reduce it? Now looking at this 50 and 25, we can easily say that it goes in 25 time table. Why to take 5 times table? 5 5s are 25, 5 10s are 50, and again reduce that. So directly can we take this 25 times table and can we reduce it? Yeah, we can reduce it. This is equal to, let us see, 25 into 2 gives me 50, and 25 into 1 gives me 25. So 25 ones are 25 and 25 ones are 25, which is equal to 2 upon 1. Now this is equal to, we have to express it in ratio, 2:1. So we got the ratio as 2:1. Now, if you see here, we have got the next sum as years and months. Very easy it is. As we know, we have to convert it into a same unit, into the same quantity rather. This is years given to me. This is months given to me. This is years given to me. This is months given to me. Now we have to convert both the years into months. Here also the years into months. Easy, we will convert it. This is the solution. First, what we will take? 1 year. 1 year has got how many months? 1 year has got how many months with us? We have got, is it 2, 4, 6, 8? We have got 12 months, as we all know that 1 year has 12 months. Similar to the sum or the previous sum, similar. Here we have 3 years and we have 4 months. Let us convert this. Now 3 years and 4 months. So what we have? 3 into 12 plus 4. Simple. What does 3 into 12 gives me? If you multiply 12 ones are 12, 12 2 is a 24, 12 3 is a 36 plus I have got here 4 months. Now 36 plus 4 gives me 40. So I have got 40 months. Let's see the next one. I've got 5 years and 8 months. 5 years, 8 months. Let us convert 5 years to months. To convert 5 years, what we are going to take? 5 into, how much 1 year has got months? It has got 12. So 5 into 12 plus 8. 5 12s are gives me how much? 5 ones are 5. If you calculate 12 5s are gives me 60 plus 8. And 60 plus 8 gives me 68 months. Now let us find the ratio of 40 months to 68 months. Ratio of 40 months to 68 months, which is equal to, when we are finding the ratio, as I told you, 40 upon 68. Now let us see any table where we can get this. Can I use, as I say, see the units placed 0 and 8. Can I use 4 into 10, 40, and 4 multiplied by which number will give me 68? 4 10s are 40, 4 11s are 44. Let us see, 4 17s are what we get. It's 17 into 4. 7 4s are 28. 4 ones are 4, 5, 6. We have got 68. That means if we multiply this 4 by 17, we will get 68. So we have got 4 into 10 upon 4 into 17. 4 ones are 4, 4 ones are 4. What we get here is 10 upon 17, which is equal to, when we express this into ratio, we get 10 is to 17. I hope these all four sums we might have understood. All these four sums we will understand all the four sums, and very clearly each and every topic is explained. Okay, if you want, we can do the next sum also, but we will stick on with the fourth sum: 3 years, 4 months, 5 years, 8 months. In the next session, we will carry with the next sum, that is 3.8 kg and 1900 grams. So, thank you, children, for watching this